Hi Niall, Sean O'Neill here for Slfx CA2. This I'm just going to go from the PDF again. So the 3D scene that I created is very basic. Did it inside FX Composer. It's just 3 teapots at differing distances from the camera. I use this to demonstrate the depth of field, and the bloom works the same on it anyway. It would work the same on any image teapots. It's just so I just kept the 3 in to keep the scene simple. For the depth of field filter, I'll go into it now. So this is my depth of field, or DOF.fx. For this one, I pretty much I imported the starting one that we had done in class, and I just went with that as my starting point. And as you can see here, this is the output. This is my 3 teapots, my 1, 2, and 3, at differing distances, and it looks, to me anyway, the furthest one's very blurred here. The middle one is the least blurred, I think, and then this one has a bit more blur on it, which it should be, as it should blur as it gets towards the near focal plane and the far focal plane, but towards the focal point in the middle, it should be the least blurred. You can change the COC value as you had implemented to make it more or less blurry. I have mine, I think it looks nice at 1.75. It's got a decent bit of blur, but it's not too blurry. In the PDF, you say the algorithm should take as input from the user the near, far, and focal distance. That is done not within the material itself, but within the camera, which is over in Assets. We go to Cameras, the perspective camera. It's the aspect ratio, and then the near and far focal plane. Focal planes of the camera. So I think that was the way you worked around it in class. The second point is the variable diameter Poisson disk blur to the original scene image, and then it should contain 12 randomly generated points. I went with what you had in the code. Down here in shader functions, pass 3. The 3x3 kernel minus the center. So we have all the different points, and there's no 0, 0. The center's not in there. I added the center to this one for my second material, my second shader, but I'll get to that later. Other than that, that's pretty much my DOF filter, my DOF shader. It's pretty much the one that we did in class. I did, of course, make it my business to understand what we'd actually done, so I went through all of it, and I used my understanding in the second material, the second shader, and for this one, of course. But we did a lot of this in class. I'll go into my second one now. So I'll just go into the PDF again. So we have the bloom filter with the fixed luminance threshold, and that's saved as bloom.fx. And it has the scene, then the full size render target, and then you go to all the bilinear filter twice, and then the bright pass filter and the Kawasi filter. I think I got down to bright pass filter. I wasn't sure how to implement the Kawasi filter though, or the tone mapping, or the what's it called? The mapping, the next one. Yeah. No, not the time dependent, the glow map. I wasn't able to implement the glow map. So if we go back to FX Composer, this is my bloom. I'll just drag it onto the scene, and hopefully it doesn't break. This is what I was able to achieve. It doesn't matter that there's 3 here because it has no depth of field or blur or anything, so I'll just zoom into the middle one. It has, I'll try to get as close as I can, some highlights, so some white highlights here, well, grey, some light grey, and then darker grey pieces, and anything that falls below the threshold, the fixed threshold that I have of 0.4, just gets returned as black, whereas the ones that get returned, the ones that are above the threshold, actually get their colour returned. I'll go to where it's implemented now in a second. So for this one I tried to, for the bilinear filter, I knew that we needed different render targets, so we need a half size and a quarter size, or a quarter size and a 16th size render target. So you were saying in class to divide by 4 and then divide that render target by 4. I wasn't exactly sure how to do it because it's a a non-object oriented language, so I found that I think that kind of just threw me all over the place. But I do know that this is where you declare render targets or create your render targets. So I kind of just went off these. I saw that it was a texture 2D, then the name of it, and then I think this is the storage location for the name. So I want a render, and I want the color target as well. I want a render target and I want it to be color. So I went with the render color target as it seems like it was the best idea. So the two that I created are called bilinear 1 and bilinear 2. I created bilinear 1 and then just copy pasted bilinear 2. But the way it is the first bilinear viewport ratio 1 is a quarter, so it could be 1 and 1 as it is here, and here, and here. But I went 0.25 because that's a quarter, and that should give you a quarter size render target. The format, you say up here that A16, B16, G16 and OR16, it's a bit unnecessary because you have extra information on the G, B and A channels. That's what you say up here. And I know it's overkill, but I thought it was probably the best one to go with because you're losing information, you want to kind of have the best starting picture to go with. So I wanted the highest quality that I could get because you're going to lose information when you quarter it and then when you 16th it. So I thought that since you're ending up with a much smaller and probably more efficient finished sample with the 16th size one, that you'd be able to spare a bit more here and then you'd make up for it in the long run. So then I copied that and I put it down here, and I got my calculator and I divided 0.25, well, multiplied 0.25 by 0.25, and that got me 0.0625, so that should be 1/16 of a render target. And then I went down here. This is where we did our cameras. I meant to mention this in the first one. This is where we created the cameras that for the perspective camera that we then bound to give us the depth of field, because it wasn't working from just regular perspective. And this one, yeah, it still does the camera. It's still showing the camera. It's getting that artifact that we were getting, where it shows the camera's view, but just also on the projective view. Perspective view, sorry. So I'm going to just switch it back to perspective. There's our lights. There's our structs. Here's the stuff that you had already put in. I think I left that because I was too terrified to touch it, and I was afraid everything would fall apart in front of my eyes. So I left the stuff that you had in, and then in Pass 3 I made some changes. I pretty much, for this one, I copied the one that you had, the one that we done in class, the depth of field one. I did that, and then I changed it to this. Well, I copied and pasted it here, so then I'd have the kernels and everything. I then commented this out because I wasn't going to be using a 3x3 kernel, and then I got the 5-point star kernel and added in the center. So it was stopped. It used to stop there. So I added in this one because the ones you want are the center point and the 4 around it. I think the way you're supposed to do it is the corner ones, or maybe that's just for the quasi filter when I was reading into it, are the 4 points on the corners, but the way it's done here, instead of kind of having a center of a box with the 4 corners, it's a center and then almost kind of a cross around it, or a plus, I guess, with this 0, 0 being the center of the plus. Your tap size is 5 because you have 5 points going into it. I then have down here, pass 4, I took in the luminance stuff from the exercise that we did in class, which had the threshold and the luminance weights. So I kept the threshold at 0.4, as it seems like a decent threshold. The luminance weights then are the psychovisual parts of it, so how much or how sensitive the human eye is to different light colors. As I'm sure you know, I'm just letting you know that I know it. Then we take in color depth, because we're going to need color depth, and we use it in luminance. That's this lumen value. For the lumen value, we get the dot product of the RGB of the color depth and against the luminance weights. So this gives us the psychovisual weights of the RGB for the color depth. So that's this stuff here. So it alters them. It sets them to be weighted more according to what the human eye can see. And since it's dot product, it puts them in the range of 0 to 1 if they're not. And then this allows us to compare to the threshold a lot more, well, a lot better than if it wasn't between 0 and 1. If it wasn't between 0 and 1, it wouldn't work correctly. So then we test in an if statement if the lumen value is greater than the threshold value, which is 0.4. Then you return, which is then displayed, the lumen, so the actual value for the O, G and B channels against the 1, because you want it to be opaque, you want to be able to see it. And that's what gives us this lumen value, is generally what gives us the different colors of grey on the finished product, I'd say. Some of it is, of course, obviously differences in brightness, but it could also be differences in color. So where it's darker, it could be a blue, because we're less capable of seeing blue. And then where it's brighter, it could be a green. So that's the middle one. And if it's not greater than the threshold, you return black, which is 0, 0, 0, and then 1 for opacity, which is where you get these black splotches from. I was going to add pass 5 for the shader function. That was going to be the quasi filter, because Lucas posted a post on the Facebook page for this website here, the chrisoat.com papers, which was scene processing. That seemed like it was quite good. I think I had a quick read through it and I picked up 1 or 2 things, but they had an example of the filter that Quasi made for the game Reckless, which is the Quasi filter. And yeah, I had a look at it and it was a bit too, I don't know, I just couldn't wrap my head around it. The way it has the top left pixel and top right pixel and all of that, I wasn't sure whether or not we were doing that already within the 5-point kernel. I don't think we are, because this is, as I said, a plus shape, whereas this one down here is like the top left and top right, so it's getting the corners of a box and then averaging them. So I just wasn't really 100% sure, and it just kind of confused me, so I left it in to show I had a look at it, and to be honest, just kind of trying to grab some extra points. And then I just commented it out because I didn't understand it, and what I've got there is an exact copy-paste of the Quasi filter that was found in the PDF, so I didn't want to get any plagiarism problems. The last thing I did then was added in a 4th pass. I changed pass 2, added bilinear 1 down in here to show my bilinear filter, and then I added in a 4th pass, which I'm pretty sure was a copy-paste from the luminance exercise, one of the passes in that, which got me this bright pass, hopefully. That's all I have implemented for this CA. I want to thank you very much for listening and wish you a nice holidays.